Hey, in this video we're going to talk about powers and exponents. So most people know that multiplication is repeated addition. So if I had something like 3 times 4, I could also write that as 3 plus 3 plus 3 plus 3, which equals 12. But now we're going to move on to a different type of way to write numbers, and that is with something called exponential form. Exponential form works like this. We have a really big number, which is a base, and that's the number that I'm going to be multiplying, because exponential form is essentially something called repeated multiplication. So my base is 3. My exponent, or the smaller number up top there by the base, is 4. So what exponential form tells me is that this number that I just highlighted is 3 to the power of 4. What that means is I'm going to take that base number and multiply it by itself 4 times, which would give me 3 times 3 times 3 times 3, and we call that expanded form. Then, if I multiply 3 times 3 times 3 times 3, that gives me 9 times 9, or 81, which is right there. We call that standard form, or the actual value of the number. So that's how powers and exponents work. In this chart we have here, we can take our power or our number in exponential form, and we can break it down into its base, exponent, as well as the repeated multiplication, and then put it again into standard form. So we'll do a couple for practice, just to make sure everyone's on the right track. So the first one, like I said, I read this as 2 to the power of 6. My base here is 2 and my exponent value is 6. This tells me I have to multiply my base number 2 by itself 6 times. And my answer in standard form is 64. The next one, I got 4 to the power of 4. My base is 4, my exponent is 4. I'm going to multiply my base number by itself 4 times here, and when I multiply that out, my product in standard form is 256. The next one, 8 to the power of 2, base is 8, exponent 2, 8 times 8 is 64. The next one, I have 5 to the power of 3. I take my base of 5, my exponent of 3, as repeated multiplication I have 5 times 5 times 5, which is 125. And the last one, 9 to the power of 1, my base is 9, my exponent value is 1. In repeated multiplication, I actually just write down the value 9, and 9 to the power of 1 is also 9 in standard form. Down below here, we can see some common exponents. And common exponents are exponents or powers that we will use a lot in other types of mathematics. And the first one, you can see here, are ones called square numbers. And a square number is essentially any number to the power of 2, which essentially means we multiply that number by itself. So, we call them squares because if you think of a square that had a side length of 1 and 1, if I multiply that area together, it's going to be 1. If we continue the pattern, you can see 4 to the power of 2 is 4 times itself, 4 times 4, which is 16. 5 to the power of 2, 5 times 5, 25. 6 to the power of 2 is 6 times itself, 6 times 6 is 36. 7 to the power of 2 is 7 times 7, or 49. 8 to the power of 2, or 8 squared, is 8 times 8, which is 64. 9 to the power of 2, or 9 squared, is 9 times 9, which is 81. And then 10 to the power of 2, or 10 squared, is 10 times 10, which is 100. As well, there are powers of 3, and we call those cubes. The reason we call it a cube is that a cube has the same length, width, and height, and if we're to multiply those together, we would end up with 2 times 2 times 2, or 8 cubic centimeters, or, as a power, 2 to the power 3. So we'll see squares and cubes in varieties of other strands of math, especially in area, with measurement as well as volume in the measurement strand as well. So hope this helps you understand powers and exponents a little bit better.